So we are talking about that this intermediate output, it will become a part of the sum. Not only this weight that we have here, for example 1 to 1 weight that we have here, and then we have C1 weight, it will be added, summed up, and then there will be a activation. It will pass through the activation. Let's look at this example. So we give an input, this is your input vector x1. For example, this is your actual input, which has x1, x2, like this up to xn. So this is your first x1. When you give it, it will be input into your hidden layers. The output of this hidden layer will be passed on not only to your output layer, but it is passed here, but also it is passed to the intermediate hidden layer output. Intermediate hidden layer output that we have here. And in the next step, now this value is stored here in these k nodes. So if we have k hidden layer nodes in the first hidden layer, so we will have k intermediate hidden layer outputs, and they are stored here. And this is the cycle that we are talking about. This is the cycles that can form within your network. So for now the data is stored, and the next time your input comes, now x2 for example, it is going to be your input. So we will have the input not only from here, but we will also have one from your intermediate hidden layer output, so this is your hidden layer output. And then of course it will do some summation, and then it will pass it to the activation function, and once it passes through the activation function, we will have your output. So here we have shown that you will have an input and you will have an output, but there are some network configurations for your RNN networks or LSTM networks where we don't have the output for every. There is no one-to-one correspondence between your input and your output. There could be other types of configurations, like you can have many input and then you can only have one output. For example, binary classification. You could have many inputs and you can have many outputs. For example, your machine translation. So there are different models that we can use depending on our research problem at hand. So this is the cycle that we are saying, that there will be a cycle that will be maintained. So we have like 3 parts. We have the input side, and we have the hidden layer, and this is your intermediate hidden layer output. So you not only pass your x of t, your current time t is your current time, and you will have an output at your current time, and not only that, this is your input, and one other part from this component, this is your previous hidden layer output. It will become a part of your summation part, and then you sum those weights, and then you do the activation here, and then this is passed on to your output. So this is the cycles that we have in our network, in recurrent neural networks. And why do we need to have the past information? Because we want to have temporal information. And remember that your CNN networks, remember that they did not have your, only depend on your current input. Whatever you have given, the current input state, it will lead to classification, binary or multiple nodes that you have a binary classification, multi-class classification problem. So there we can say that it has no memory, but we can see here this part, we can say it has some level of memory. Why we call it memory? Because it is from the previous timestamp. This is timestamp t and this is your timestamp t minus 1. So if we are getting some information or we are giving some input from the past, we say that your network can have a memory. So CNN algorithms, therefore, they cannot handle the sequential data that well, and for that, or RNNs are there, where we not only consider the current input, but we also consider your previous input. So current state as well as the previous state will take part in determining the output from the hidden layers. So we can see that these are the cycles that we talk. So input at time t, hidden state output, then activation function, and now I introduce you to these three weight matrices. So we already know that there are weights between each components in each layer of your neural networks. Here we call these as W, U, V, and W, these weights. So the weights between your input and your hidden layer, they are referred to as matrix U. Between your current hidden state and your intermediate hidden state, we call that W, and the output and the hidden layer T, the weight matrices between these two nodes or the layers will be your V matrix. Remember that one more information I want to give you here, that these UVW, they share the same parameters across all time steps. So here we have now come across one new concept of time steps. So what is time steps in your recurrent neural network or your LSTM networks? What are the time steps? Let's have a brief discussion on the concept of time steps. Okay. So what are the time steps? First, I will give you a basic idea. Okay. So whenever we are going to give input into our RNN type neural networks, recurrent neural networks, or LSTM networks, this is our sequential data, okay? And we are predicting what comes next after E. So this is the input at time t. This is at input at time t minus 1, t minus 2. So, okay, let's change. Okay. This we say is the input at time t, and previously we gave input t, then we gave C, B, t minus 3, and then at A it is t minus 4. So how many time steps? We go back 4 time steps. The total input is 5 time steps. How many time steps or time periods are we going back from the current state? Here we can say that this time period, or the estimation of our time, is 1 millisecond. It could be 1 week. It could be 1 month. Okay. It could be 1 second. So what is the definition of time? It depends on your application. For example, if it is stock price prediction, it could be like the current week's stock price prediction. And following on that, t minus 1 would be the stock price prediction 1 week prior to